For those of you who have joined early, we'll get started at the top of the hour. For those of you who have joined early, we'll get started right at the top of the hour. Thanks. Hi, Katie, just doing a sound check. Can you hear me all right?
Yep, I can hear you.
Thank you. Hello, everyone. Welcome to today's webinar, Why Do Your Analysts Need to Know SQL? So my name is Alex Christensen. I've been working as a data analytics trainer and consultant for about a decade now. I started my career as an internal SQL trainer for a small telecommunications software company, mostly working with Microsoft SQL Server and IBM DB2. Since then, I've expanded my expertise and I've worked with Alteryx, Tableau, Snowflake, Cloudera, and the IBM Analytics stack. My focus has always been on strategy, enablement, and training. Essentially, how do you get a department to be more effective and self-sufficient? I'm also one of the partners and co-founders at Tessellation. Here, I oversee our data coach program and platform. On this tool, we pair enterprise cohorts of trainees with expert coaches to facilitate, accelerate, and improve the overall usage of the analytics tools that they use. And I am really excited to be here today to talk about one of my favorite programming languages, SQL. I'm very fond of SQL. It's how I got into data and analytics to begin with. Note, this is not a demo or a training on introductory SQL. Rather, it is we're going to focus on the reasons why business leaders and the analysts who report to them should focus on investing in learning SQL as a top priority if they don't already know it at an intermediate or advanced level. We should have time at the end for questions that you can submit through the platform. So, what is SQL? SQL, or SQL, stands for Structured Query Language. It is the most common language for reading data from our underlying data warehouses and the corresponding systems and databases and schemas that go along with that. We can pronounce the language as SQL, or we can say SQL. Both are acceptable, but it's probably more common to pronounce it as SQL. You'll probably notice that I switch between the two. That's a habit that I've been doing over the last 10 years or so. The language itself is old. It's over 50 years old, and it was first developed by researchers at IBM in the early 1970s. So what is SQL not? It's not a scripting language. What it really is a simple programming language that lets us use a set of instructions called commands to manipulate and extract data from a relational database. So to use SQL, we have to write a query. And here's an example of a simple query that we could write within a SQL environment. So the query does a couple of things here. So it is going to return all the rows from a table that we specify, which is called orders, where the filter is set to the year 2021, and we're going to order all of our results by month. So if you're not familiar with this, again, like I said, this is not a training on SQL itself. We're going to talk about how it applies within the business. But just to level set, this is what the query is doing. It is selecting all records, so all rows from a table. So the asterisk sign after the select means select all of the columns for the corresponding rows within the orders table. So that is the from line. The from says, where are we getting our data from? Our where line here is essentially our filter. So we'll have logical and comparison statements. And instead of returning every single row, we are only going to return the rows that have the year field that's equal to 2021. And we're going to sort our data. We're going to use the order by statement to sort all of our data by the month field. And this would sort it in an ascending order. Now, a couple side notes here. As I mentioned, we use an asterisk symbol when we want to return all of the columns. We use a semicolon at the end to separate queries. Overall, there are lots of variants of SQL with slightly different syntax and commands that are needed. Where do you put certain symbols like the semicolon, or what quotation marks do you use? But compared to other programming scripting languages, even with those subtle differences between the variants, SQL is very straightforward to learn. There are only a handful of essential commands that exist between all variants of SQL, but once you've learned them and gotten familiar with them, you can assemble these commands in different ways to get all of the data that you need from a database. I always think of it as the components itself are very simple and easy to understand and easy to learn, but over time you can assemble those simple components in more and more complex ways for more and more complex use cases. So, why are we talking about SQL? Usually when I do a webinar like this, I focus on something newer. kind of the best in class, newest technologies out on the market, whether it be a feature, a concept, or a new tool in its entirety. I usually talk to the group about why this new thing on the market is the best new thing on the market, for lack of a better term. That's not SQL. Like I said, SQL is 50 years old. So this webinar is going to be a little different. We're going to be focusing on a tool that's been around for a very, very long time. But just because it is old, it doesn't mean that it isn't relevant. It's starting to have a resurgence as a tool within the market over the last couple of years, particularly on the business user side. So what's changed? SQL used to be the exclusive domain of the IT department, but this has changed quickly over the last couple of years, like I mentioned. So over this last decade or so, companies have started to focus on data-driven decision-making initiatives or data-driven culture initiatives. And though that's just a trend in the industry, and I'm often skeptical of trends, I strongly believe that in this case, it's a good direction for companies to move in with some very, very positive outcomes. Essentially, everyone is looking at the data to help make better decisions rather than just going off of the status quo or gut instincts like a company may have done in the past. So if this used to be the domain of IT, what's changed? What's changed over the last couple of years? What's driving this trend? Why should all analysts on the business side, in my opinion, focus on learning SQL? Why am I advocating for expansion and usage of this tool in 2021, 50 years after it's been created? Well, the data landscape has changed quickly, particularly for large companies over the last 10 years or so. And two really big things come to mind for me that really caused this shift. First, and a little bit more legacy in the systems, going to big data lakes like Hadoop really helped cause that shift. And then more recently, cloud computing as kind of a go-to for enterprises has really motivated the shift for business analysts to learn SQL as well. So let's talk about that a little bit. So starting with Hadoop, I want to talk a little bit about how this really changed the landscapes for companies. So I personally put a lot of the change in the shift towards business-centered SQL users on the rise of big data technologies and data lake technologies like Hadoop. If you're unfamiliar with Hadoop, no worries. I'll give you a quick background on it. So Hadoop is an open source framework that really revolutionized the way companies store data. Essentially and simplistically, it allowed companies to store massive amounts of data, terabytes on terabytes on terabytes, in a relatively inexpensive fashion for the first time. Essentially, what Hadoop is from a hardware component is it's just a series of inexpensive commodity hard drives. You can think of it as you, as a user or an IT department, could go to Best Buy and buy the hard drives that you would network together to make, excuse me, you could go say to like Best Buy and buy the hard drives you needed to network together in order to create a Hadoop big data cluster. So it was really inexpensive. Really what the secret sauce to it is how they networked these hard drives together, and you were able to store massive amounts of related data across multiple machines. And this was revolutionary because before then, if you had terabytes and terabytes of data, you would have to pay for a very, very expensive machine, like a single machine for storing that data. So before Hadoop, companies that had massive amounts of data were paying millions of dollars just to store their data. But Hadoop essentially took that hardware cost down from millions to tens of thousands of dollars in range for the companies that were using Hadoop from a hardware perspective. This was completely revolutionary. companies were storing and literally storing all of their data for the first time. And that really helped fuel kind of the trend of data is power, meaning that the more data we have, the better insights we can glean for our company. Sounds great, right? Why isn't this kind of the leading technology? I will say that companies still use Hadoop. It's still a part of larger ecosystems. It's just not the focus it was anymore. There are some problems with Hadoop that came along with this surge. We now had all of the data in one place. IT had essentially done its job. They figured out a way to inexpensively store all of the data for a company for the first time. Great, right? Well, there were some unexpected consequences and realizations that came over time because of that. Basically, the data just became just sitting there and no one was analyzing it and finding those new insights. And I see this as due to two issues. Though Hadoop was really, really good at storing these large amounts of data, getting the data out of the system was somewhat of an afterthought with the design. There wasn't as much structure on the data, and it was a much harder system, particularly for business analysts to use. It was just hard to get the data out and just was not super usable. Second, there was a lot of difficulty with getting data out of the systems. The business users really didn't have the resources they needed in the first place. The skill sets to do this, like SQL, really weren't readily available across all of the business users. Plus, this was a very difficult environment even to use a simple language like SQL within. It was slow compared to some other systems, particularly when you're connecting reporting tools like Tableau to it. And business users really started to get annoyed with this product. So these issues really pushed the skill sets of the analysts, and if they wanted to analyze this data, they had to start to become scrappy. Now, obviously, I just talked about a lot of negatives of Hadoop, and this is not a discussion advocating for Hadoop. That trend as kind of the top trend really has come and gone. However, its legacy really does remain. Because of this big push within the data and analytics market, for the first time, business users knew that they have access, at least theoretically, to massive amounts of data that they can use for their job. Now, let's move on to the next trend, the more incumbent trend that really started a couple years after Hadoop was a big player. Now, this is the cloud computing trend, and I'm sure everyone to some degree knows a little bit about what cloud computing is. It's becoming ubiquitous. So it really has started to take over the data storage space, I would say, in the last 5 years overall. Within the last 2 or 3 years, we're seeing companies really put a large emphasis on moving their data reporting environments to the cloud. So let's give you a little background here on how these systems work, because I think it will overall make it be a lot more apparent why we're going to have business users really focus more on languages like SQL in the long term. So I always like to talk about a computer science a concept called abstraction. So abstraction is where the tool someone is using is taken to another level further from the underlying system, really moving one level up. And I'll explain what I mean by that in a little bit. So every time you move up a level, the tool gets easier to use. So let's start by thinking about what a computer is and does. A computer is just a long string of ones and zeros, or you can think of it as even switches, an on and an off. So these long strings of ones and zeros usually represent something, a task, and that's a task that the computer needs to perform. But computer scientists, most of them, and particularly people who are working in industry, they don't worry about these ones and zeros. it would take way too long to write a computer program that is all ones and zeros. So an example I always like to talk about is the original Tetris game that was on the Nintendo Game Boy was 32,000 bytes. And there are 8 ones and zeros in every bytes. So the entirety of the program for Nintendo's Game Boy Tetris would have been over 250,000 ones and zeros long. Now, technically not impossible for a single individual to write a string of 250,000 ones and zeros. It would be pretty tricky and super time consuming. And it's rather improbable that anyone would actually do that. First, the ones and zeros aren't super readable for humans. Second, imagine if you had an error within these ones and zeros. It'd be like finding a needle in a haystack, probably harder actually. So this is why we created programming languages. So each operation we write using words, an operator, or a function corresponds to an underlying 1 and 0. And then on top of that, the next level that we write will reference kind of the underlying languages, which then represent, go to the ones and zeros. So every time we go that one level up, it becomes substantially easier for the end user to do something within a platform. This is what really abstraction is. So the reason I like to talk about this, and I was probably rambling on about that a little bit more than I needed to, is software as a service, which is another name for cloud, is really that newest form of abstraction. So previously, an administrator would have to do the configuration, installation, and maintenance of both the software and the hardware, run all the tasks within the data warehouse environment. So moving to the cloud really took this another level away from the underlying systems, making it much easier to run and maintain. So resource management, for example, is the largest simplification when we see moving to cloud warehouses when they became available. So no longer do you need to set up the hardware, which is really just the server machines, like you would with Hadoop, to run your data warehouse. No one is physically setting that up anymore within an organization. Yes, still someone at AWS, Azure, or Google, or IBM, they're hosting the machines for us. They take care of all of that setup and enablement. So these automatic software updates that come with it are another considerable advantage of cloud-based data warehouses. If you've ever been part of a server upgrade on a database or really any analytics technology, particularly if your company hosts the hardware itself, you know that these can be challenging projects. You have to create test plans. You have to schedule the backup up. You have to get ready for the outages. It can be very time consuming from both a time and a money perspective. Cloud-based software and hardware really makes this process significantly easier. You're essentially using the latest version of the software whenever you log on. There's no need for a large project, to update users' machines or companies' servers. So this optimization on how the speed and availability of data is collected and is available for analysis is the most apparent advantage when we move to the cloud. These tools do a lot for query optimization right out of the box for us. So you could expect that the exact same data on your Hadoop data lake, that's your legacy system, and the exact same data that's out in the cloud in a system like maybe Athena or Snowflake will perform better when you run queries against it. So admins and even the business SQL writers spend a lot less time optimizing query performance on these cloud-based data warehouses than the legacy counterparts. Now, that's not to say that there's zero management. I need to be honest there. You still have to do some optimization configuration. It's just comparatively less and a lot less supervision than the legacy counterparts. So that's really what the core advantage that I see with cloud-based technology in this space. Now, some of the other advantages with software as a service platforms in the cloud could be simplified user authentication, security and data management improvements, automatic high availability, another word for disaster recovery, and another big one would be scalability and flexibility of scaling up and down your environments. So really what this comes down to for me is the trends of both big data and cloud environments really meant that organizations started to have more data-driven cultures. There was more data being stored for the first time. With cloud, the tools became much easier to use and easier to scale. And that kind of meant that SQL can now be for everyone. It doesn't have to be just part of the IT department or even like the true data science department going forward. SQL's having a renaissance because of this. So we see this at Tessellation Data Coach as one of the most in-demand skills for both our team, for the clients that we're working with. It is becoming really essential for anyone who has an analyst title. Now, you might be thinking, hey, Alex, what about dashboards? That is a really big trend that my company just is really just starting to master. Creating dashboards, visual analytics. Why isn't this sufficient? Well, that's true. And we think that dashboards should continue to be kind of the center of reporting and analytics for any organization. However, there's an issue, and that issue we do need to address and illuminate. So I think about good dashboard design, and this is what we advocate for here at Tessellation, is it's like a good museum exhibit. So everyone starts at the same place and ends in the same place, but you can learn different things along the way. You can take your own path. I can start at the beginning. Maybe I go to the archaeology area, from there to medieval artifacts, to postmodern art, to cafeteria, back through medieval artifacts to the exit. I've learned something different, something that I care about that is different from someone else who was in the same museum at the same time. So you can translate this museum analogy to a set of dashboards. So maybe it is a HR KPI dashboard. So you start at the beginning, you see the executive level KPIs, how is your company or your department doing? But then you can drill in and see something different. So maybe my next question is about employee attrition, which leads to recruiting. Those sort of paths is what a good dashboard set of dashboards, I should say, is designed within reporting and analytics nowadays. However, even with this great, best-in-class design, there's an issue. And the issue is that you can't design for everything. There is always going to be ad hoc questions du jour that analysts need to be able to answer to do their job. You can do a lot of planning with dashboards. You can address a lot of possible questions, but it's nearly impossible to set up a dashboard for a self-service environment that answers 100% of the possible questions that a company might have. That's when SQL really comes back into play, is within that ad hoc space, and particularly for kind of business analysts. So this is an important skill that we need to equip analysts with so they can really be successful at their jobs. Now, I do think that there's a secondary reason why SQL is important for modern analysts to learn. Most data and analytics tools that are used within an enterprise are abstraction again, of the SQL language. So using Tableau, for example, it's a tool that I use a lot. The underlying language is called VizQL, and all VizQL is it converts a visualization request into simple SQL queries that's sent to the underlying database. The underlying database returns the query results, and Tableau assembles that into a visualization. Alteryx, another common workflow automation and advanced analytics tool that I use, is an abstraction of SQL as well as also an abstraction of advanced analytics languages like R and Python. And we just run the SQL code, and we don't necessarily need to work with SQL experts there. So this is the trend almost across the board with all modern data and analytics tools. I think it's very important for analysts to understand, at least at a high level, how does SQL work, because that is going to be how the tools are working behind the scenes. So if you know how a tool is working behind the scenes, you're going to be better using that tool, particularly when you're addressing an issue or you're doing performance tuning. Understanding what's happening under the hood is only going to be beneficial for using those tools. So what variety, let's say you are brand new at SQL and you don't have anything in your organization, what variety should you use? There's hundreds out there. Really what the best in class one right now is Snowflake. So Snowflake is a SaaS cloud-based data warehouse, super easy to use. It is really the big driver for business side SQL query writing based off of its scalability, flexibility, ease of use. This is our recommendation. By no means is it the only thing to use. A lot of enterprises have made decisions for their environment based off of their specific needs. But if you are an analyst on this call and you're wondering where to start, this is a great place to start. All right, I'm actually going to pause here for about 5 minutes or less for questions before I go into Data Coach Tessellation's approach to learning SQL. So you can type in a question via the QA functionality. I'll give it a moment to see if anyone has questions to submit. Also gives me a chance to drink a little bit of water. I'll give it till the 30-minute mark. All right, didn't see any questions come in. That is all right. I'll have time for questions again at the end if you think of anything. And now I'm going to jump into kind of the more Data Coach tessellation specific approach to learning a skill like SQL. So Data Coach itself, and I'll do a short demo at the end in case you haven't seen the tool before, is an overall solution. We combined a program that is really set on driving engagement, adoption, measuring ROI, with a best-in-class platform with some of the best data and analytics training out there. And that really creates an environment where you can scale the learning of an analytical solution like Snowflake or SQL or really anything within an organization. So we do a large focus on program. So the reason we do a large focus on program is we think that this is the secret sauce for people to truly learn a new concept within data and analytics. The first thing that we do is we like to pair individuals with a capstone project. So they can select a project from an enterprise's backlog of data and analytics projects, and they will work on that project while they are learning that new skill or tool along the way. Now, managers tend to like this, and I think rightfully so, because you're getting something concrete and tangible at the end of a training engagement to really show the return on investment of that program. Now, that ties to the second one, which is the skills and ROI assessment. So we think it's really important to measure both what is the impact of the projects that individuals are making as part of our training, as well as how have the skills increased from beginning to end. One-on-one coaching is another core thing that we focus on, where our training isn't just videos and PowerPoint presentations. We do have those, but really the important thing is that trainees can work one-on-one with an industry recognized expert who has been a career trainer or a career consultant for years, and they can have that as part of their training. And then finally, a large thing that we also help with is community management. So things like organizational data literacy, best practices across departments, doing internal marketing and webinars. These are the 4 core things that we think are super important for an organization to be effective in learning a new skill like SQL. So from a platform perspective, some things that we do are structured learning plans. So that is structured courses that individuals can go through. So multiple courses in a learning plan. A course has lessons, those lessons have topics, very structured ways to make sure that you understand all of the important things within a tool or concept. We also do a lot with unstructured content. So bringing in some of the best content from like blog posts, podcasts, YouTube style training videos, really for ad hoc learning. Connecting with a coach via one-on-one and community building via forums. And we also like to sprinkle in a healthy dose of gamification and by badges and points and leaderboards, and being able to have people share those badges with the rest of the world, such as with LinkedIn. Now, that is an overview of what is the Data Coach platform, but let's actually take a look at what's available for a data and analytics perspective. And I actually meant to go to a different site for the demo. Apologize. So I'm going to log in as a user to Data Coach. And this is what a new user will see when they log into the platform. So this is the learner dashboard. And what I can see here in the middle are all of the courses from our structured learning plan that I've already started. So I'm going to go in here and I'm going to take a look at one of our SQL courses, SQL on Snowflake Foundations. So from here, I have what's called the course player page, and we have a couple of items that are super important to go through in order to be successful in learning this tool, but also across tools, and I'll call some of these things out. So I mentioned that we do pre-skill surveys. This is a great way when you're working with your analysts or even you as an individual to measure how much have I learned, and it's integrated within our platform. So it's going to ask me what's my name, email address, and rank my skills, and then rank each of the learning objectives throughout the course. We ask people the exact same questions again at the end of the course so we can help measure their progress. So another thing that we do within our trainings that I think is super important is we focus on concepts and tools itself. So in this case, the concept is SQL, and the tool in this case is Snowflake. But these conceptual concepts will apply across all tools that are SQL based. On top of that, we talk about conceptual topics that are really helpful, that are related and outside of the tools. So for example, this chapter, lesson chapter that I'm going into, teaches the concept of relational databases. So why do we use relational databases? Why do these relational databases have multiple tables? What's a key? What's a schema? So we have this information available for all of the people who are learning, because we feel strongly here at the Tessellation Data Coach team that knowing this underlying conceptual information is as important, if not more important, than learning the tool itself. Now, that's not to say that you don't learn the tool itself. So I can go into the where clause, which, remember, the where clause is our filter clause if you're new to SQL. We have examples with the where clause and the functions that are very common to use it. lessons that walk through the examples of the code, so people can understand how to use this tool. On top of that, I'm going to go to our catalog. And we have content on Alteryx, Power BI, and Tableau. But one thing I want to call out that I think is a big differentiator in learning a new tool is focusing on data fluency. So we have a data fluency track that covers what do all of the consumers of data need to know, all the communicators of data need to know, but most importantly, within this context, what is all of the conceptual information that an analyst needs to know to be successful in a tool like SQL. So here we have a course that's specifically just on cleaning and structuring data. So we will talk about how do you move away from spreadsheets to adopt data storage and analytical tools? How do you have data veracity so the quality of the data is high? What are the common operations you need to do to clean your data? We include all of this information, and we think that this is what is needed to be successful for an organization that wants to go through an initiative of teaching a large group of individuals SQL, or even a small group, really. A couple other things that I do like to call out when I'm just doing a quick demo of the platform is individuals in the enterprise can do a live chat with our coaches, and we get back to them before the end of the business day. And you can also, as I mentioned, schedule time directly with one of our coaches to talk about our tools, whether it be Power BI, Tableau, SQL, and so on. All right, I'm going to pause here again for questions from the group. Do you see a chat? From a BA business intelligence perspective, job perspective, is it important to learn a particular form of SQL, Oracle SQL, T-SQL, or employers more into aggregation, data manipulation, and window function skills? So it depends on the employer. I would say, from my experience for the companies I work with, they're much more interested in how you use the tool. So for the examples that you use, aggregation, data manipulation, window function skills, kind of the advanced skills within SQL, they're probably a lot more interested in. Now, that said, unfortunately, there is kind of an issue when you're applying for jobs, when you're going through an HR department, where they might specifically look for Oracle SQL or T-SQL just to get your foot through the door. However, I strongly feel that anyone who is an intermediate to advanced user in any variant of SQL can pick up another variant of SQL in a week. Like, the worst case scenario is you just have to Google something to look up the syntax or the action or the filter, function for that variant opposed to another. Great question. Any other questions so far, either in chat or via the question and answer functionality? I'll give it one more minute. Oh, new question came in. There are a lot of tools available, so which is mostly used? Now, that varies. And if you're talking about SQL in particular, I would say that the ones that are most used on the new side would be Snowflake, particularly from a data and analytics perspective, is probably the most common. And if we're talking more from a More from a data science side, predictive analytics side, I would say Databricks is probably the most common that's being used. Now, legacy systems are always going to be a large part of kind of the landscape for the tools. So it's hard to move off of a legacy system and to move off of it completely. There's still a need for people who can do Cloudera Hadoop. There's still a need for people who can do Oracle, who can do Microsoft SQL Server. That's not going to go away, but the expansion that we're seeing is with the cloud-based variants of SQL. Good question. All right. I don't think any other questions are coming in today. I really do appreciate everyone's time. I hope you enjoyed this presentation, and everyone have an excellent weekend. Thank you. Bye.